Good morning, everyone. Once again, welcome back to Chandra College of Science. This video is from Mathematics Department, and I am your Mathematics lecturer, Jagadish. Okay, you guys already know we started your BSc 5.2 Laplace transformation classes. In last class, we discussed about your some properties of Laplace transformation. In that, first property is change of scale, and second property is first shifting property. Okay, and also we solved some examples and some problems related to that properties. And today I am going to explain your third property, that is multiplication of t to the power n. Okay. Okay. Your third property is multiplication by t to the power n. Okay, the statement is if Laplace transformation of f of t is equals to capital F of s, okay, this is your definition, then then the Laplace transformation of t to the power n into f of t is equals to minus 1 to the power n and d to the power n divided by ds to the power n of f of s. Okay, that means differentiation of nth term into your given Laplace transformation of function. Okay, where n is equals to positive, that is 1 2 3 so on. Okay, let's prove this one. We prove the result by induction method. Okay, this property we prove by the induction method. We have in that we have f of s is equals to Laplace transformation of f of t is equals to integration over 0 to infinity e to the power minus st into f of t dt. Okay, this is your definition of Laplace transformation, and this function we differentiating with respect to s. Okay, when we differentiate this function with respect to s, we get that is this function differentiate of f of s by ds. Okay, this is as is, and this function when we differentiate this e to the power minus st, okay, with respect to s only, that's why we will take s only. These functions will get constant function, so differentiate of e to the power minus st into differentiate of minus st. Okay, here the s is constant, the s is differentiate function, s is becomes 1, so that's why here the value is minus t. Okay, so when we differentiate this function, we will get 0 to infinity e to the power minus st into minus t f of t into dt. Okay, so this function we will write this next step, that is 0 to infinity e to the power minus st into minus t f of t dt as it is. Okay, so this function we also write it as minus 1 is an outside, that is 0 to infinity e to the power minus st t into f of t dt. Okay, see here carefully, that is minus 1 into, so minus integration over 0 to infinity e to the power minus st, and this function t into f of t dt. Okay, or we will write this at 0 to infinity e to the power minus st t into f of t dt. Okay, so this becomes your constant, this becomes your function, Laplace transformation of given function. Okay, so according to your statement, okay, according to your statement, so Laplace transformation of t to the power n into f of t. Okay, this here t to the power n f of t is equals to minus 1 to the power n d to the power n divided by ds to the power n f of s. Okay, here minus 1 is function is there, so that's why you write minus 1 to the power 1. That means we have only one function to differentiate, that's why we write 1 ds d by ds into f of s. Okay, Okay, the result is true for n is equals to 1. Okay, hence the result is true for n is equals to 1. And your right second step is, it is, suppose suppose the result is true for suppose the result is true for n is equals to m. Okay, this is also true, you already know that. So we will solve once again. It is Laplace transformation of t to the power n f of t is equals to minus 1 to the power n d to the power m divided by ds to the power m into f of s. Okay, instead of writing n we write m here only, and this function we will write it is integration over 0 to infinity e to the power minus st. So t to the power n into f of t dt is equals to minus 1 to the power m d to the power m divided by ds to the power n f of s. Okay, hence, okay, wait, then next we differentiate this function as with respect to s. Okay, same here, with respect to s only. That will become integration over 0 to infinity e to the power minus st into t. So listen here carefully, that is integration over 0 to infinity e to the power minus st into minus t. Okay, you guys already know the differentiator of e to the power minus st, and t to the power n becomes constant. This all function becomes constant, so that's why we will write this as it is, that is t to the power m into f of t dt. And here also your integration over t to, sorry, minus 1 to the power m and e to the power m plus 1, that is one more function differentiating. That's why m plus 1 divided by ds to the power m plus 1 into f of s. Okay, hence this function we will write as minus t is outside, that is minus function, that is t to the power e to the power minus st into t to the power minus 1 into t to the power, t to the power m into t to the power 1. It becomes t to the power m plus 1 f of t into dt. So here minus 1 to the power m into differentiate of m to the, sorry, differentiate of m plus 1 divided by ds to the power m plus 1 f of s. Okay, okay, here okay, hence we have Laplace transformation of t to the power m plus 1. Okay, this function becomes our uh, definition of Laplace transformation, that is Laplace transformation of t to the power m plus 1 into f of t is equals to minus 1 to the power m plus 1 and differentiate of, okay, differentiation of d to the power m plus 1 divided by ds to the power m plus 1 and f of s. Okay, the result is true for m plus 1 also, that is n is equals to 1, n is equals to m, and n is equals to m plus 1. This is your induction method. So hence by the induction the result is true for all positive integer values of n. Okay, it is your final answer. It is Laplace transformation of t to the power n into f of t is equals to minus 1 to the power n differentiates to the power n divided by ds to the power n f of s, where n is equals to 1, 2, 3. Okay, or this function, otherwise we will write this as it is, means Laplace transformation of t to the power n into f of t is equals to minus 1 to the power n d to the power n divided by ds to the power n, and this function f of s, instead of writing this we will write Laplace transformation of f of t. That is our given function or given equation. Okay, we will go for next, so we will go for some example on this. Here, find the Laplace transformation of t into sine 80. Okay, listen here carefully. Here, t to the power 1 is there. That is our n value is 1. Okay, so Laplace transformation of sine 80. We already know that sine of 80. That is Laplace transformation of sine 80 is equals to A divided by S square plus A square. Okay. So you guys please cooperate. It's not proper writing here. Okay. Solution. First we will write the given equation, that is t into sine 80. Okay. Into multiplication t to the power n is there. So that's why it's we'll go for the property number 3. Okay. It is Laplace transformation of t into sine 80. So wherever we will get t to the power n is but in multiplication, on that time we use the property number 3, that is minus 1 to the power n. Okay, minus 1 to the power n t to the power n divided by ds to the power n into your given Laplace transformation, that is given function. Okay, here t to the power 1 is there, that's why we will write minus 1 to the power a1 d to the power 1 ds to the power 1. That means it's become, so differentiate only one term. If it gives square, it means on that time we will solve differentiate of second term. Okay. So here t to the power 1 is there, that means minus 1 to the power n d to the power n ds to the power 1 into Laplace transformation of sine 80. So this is your property number 3, that is multiplication into t to the power n. Okay, when we solve this function, minus 1 is there, that's why we will write minus d by ds into Laplace transformation of sine 80. It is a divided by s square plus a square. Okay, this is your sine from Laplace transformation of sine 80 property. Sine 80 is equals to a divided by a square plus a square. Okay, so we will write this function here. Now we have to differentiate this function with respect to s. Okay, so in this we will write a is constant function, that's why we will write outside. Okay, so it becomes minus a into minus 1 divided by s square plus a. Okay, we will write here first minus a outside minus 1 divided by s square plus a square. Okay, this is your function. Okay, when we differentiate this function, okay, when we differentiate this function, that is 1 divided by x square plus a square, if we have this function to differentiate with respect to s, and this time we will do, that is x square plus a square to the power minus 1. Okay, this function we will write this time, and when we differentiate this function, we will get, that means minus 1 into x square plus a square whole to the power minus 1 into minus 1 into the differentiate of x square, that means 2x to the power 2 minus 1. Okay, this function we will write, that is minus 1 into x square plus a square to the power minus 1 into minus 1, that is minus 2, and this function 2 into x to the power 1. Okay, 2 into x to the power 1. This function we will write, okay, I will write here, you have to see here, means minus 1 divided by, so x square plus a, okay, wait. Okay, here